Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem: remove all occurrences of duplicates in a linked list. So what the problem is saying is we will be given a linked list, a sorted linked list basically. And what we want to do is you want to remove all the duplicate elements. So if you see here, right, 28, 28, there are duplicate elements. So you want to remove these elements. Then we have 49 and 49. We want to remove these elements. We have 53 and 53. We want to remove these elements. So what will be the resultant list at the end? So the resultant list will be this. So this is what we want to return. Okay. So this is the ask. Now, what is the time complexity and space complexity? So the time complexity and space complexity is O of n, and the space complexity is O of 1. Okay. So now how to solve this problem, right? The space complexity, we don't have to take any extra space. Okay. So we want to solve this problem in O of 1. So what can be the intuition? So what we can do is, what we'll do basically is, we'll take a dummy node. For example, the dummy node, and we'll initialize this dummy node with the value 0, and we will point the next of the dummy node to the head. So this is the head pointer. Okay, this is the head pointer. Okay, so we took this dummy node, we pointed its next to the head pointer, and what we'll do, we'll also assign this dummy node as a previous pointer to the previous pointer. Okay, and what we'll do, apart from this, we'll also take one pointer called current, and we will basically, yeah, we'll point it to the head. Okay, now what we'll do, we are going to run a while loop. We are going to iterate through this, we are going to iterate through this list. Okay, and what we'll do is basically, we'll check if this previous dot next, if previous dot next dot data, right, previous dot next dot data, right, this data, right, if it is same to the next of current dot next. Okay, if it is same, right? So here in this case, so these values are not same, right? So what we are simply going to do, we are going to assign this to previous, and we are going to advance the current pointer to this. Okay, advance the current pointer to this. Now we'll check whether the previous dot next data, what is previous is this previous dot next data, if it is equal to current dot next data, this one, yes, this both are same, right, this both are same. So simply what we are going to do, we are going to advance the current pointer, right, we are going to advance the current pointer until we find that this data, right, this data and the next data, if they are not same, then we will break. For example, now again here we'll check if previous dot next data, what is previous dot next data, this is the previous dot next data, if it is equal to current dot next data, right? So so these are not same. Okay, these are not same. So simply what we are going to do now, previous is pointing here, right, previous is pointing here. So simply what we are going to do, we'll point previous dot next equal to current dot next, because we want to bypass these nodes, right? So current is here, so what we'll do, we'll assign current dot next, current dot next, right, will assign to the previous, right, the previous dot next. So we are pointing. Okay, so in this way we are bypassing these nodes. Okay, so simply again, now after this we are going to advance our current pointer again. So our current pointer now points to point O here, right? Our current pointer now points here. So what we are going to check again, if previous dot next, right, previous dot next, if it is equal to current dot next. No, it is not. So simply what we are going to do, now we are going to uh, assign this previous year. Okay, assign the previous year. Okay, and we'll advance our current. So also let me also code along, right, so that you will understand better. So before going to the code, I'll request you to subscribe to my channel. Thank you so much. So as I said, right, so we are going to take a dummy node, right? We took a dummy node and we'll assign the value as 0. Okay, and what we'll do, we'll take a previous node as well, a previous pointer as well, which will assign dummy to the previous pointer. Okay, and also dummy dot next, what we'll do, we'll point it to the head. Okay, and we'll take another pointer current equal to head. Now we'll iterate through the linked list, right? So what will the condition? Yeah, current. So this will be the condition. Now what we'll check? We'll check that while current dot next is not equal to null, and previous dot next dot data. If it is current dot next dot data, so let me explain this. If such is the case, then simply advance the current pointer. So I'll explain this case, right? So here, right, in this case, our previous was what? 23. Our previous was here, right? And our current was here. Sorry, 28, 28. Okay. So this is our current, right? So what we're checking is if previous.next.data, previous.next.data, if it is equal to current.next.data, right? If it is equal to current.next.data, then you increase. So why we are doing this? So that we want to remove the duplicate values, right? So we'll advance the current pointer. So that's what we are doing this, right? That's what we are doing here. If previous.next.data, if it is equal to current.next.data, we are checking for this consecutive duplicate elements, right? If it is such is the case, advance your current.next pointer. Okay. So again, now current is advanced, right? So here again we'll check. So what is previous? Previous is here. What is previous.next.data? Previous.next.data. If it is equal to current, or current is here, right? Current.next.data. Is this same? No, these are not same, right? So we'll break out of this while loop. We'll break out of this while loop. Okay. And now here we are going to check if previous dot next, sorry, if previous dot next, if it is still equal to current, right? Still equal to current. So we are simply going to do previous dot next. So what this means is that there were no duplicate elements. For example, let's see here. Let's see this case, right? So this was the dummy pointer. This was previous. Okay. This was our current, right? This was our current. It was pointing to, yeah, to 23. And this was the next current dot next node. So what we're checking here, what did we check here? Previous dot next dot data equal to current dot next dot data. So here, so what is previous? Previous is here. What is previous dot next dot data? It is here, right? Previous dot next dot data and current dot next dot data, right? So these both are not same. These both are not same, right? So simply what we are going to do, we are advancing the previous pointer. We are advancing the previous pointer. Okay, now previous pointer will point here because these are not matching, right? So we'll simply advance the previous pointer. So that's what we are doing here. Previous dot next equal to current. So in this case, right? So previous is still previous dot next equal to current. It's the same, right? It's the same. It's the same. So we are just going to advance the previous pointer. Okay. Then else in this case, right? In this case, previous dot next is not equal to current. Why? Because in this case, for example, right? Previous was here. Previous is here, right? And current is here. Current is here. How current went here? Because we checked, right? Because we checked if previous dot next dot data, if it is equal to current dot next dot data. So yes, it was same, right? So we had advanced the current pointer. We had advanced the current pointer here, right? We had advanced the current pointer here. So that is why previous dot next is not equal to what? Previous dot next is not equal to current. Current is pointing here, right? Current is currently here. It's not here. Current is currently here. So previous dot next is not current, right? So in this case, what we're going to do, we are going to bypass, right? What we're going to do, we're going to bypass the duplicate nodes. Previous dot next equal to what we're going to say, current dot next. So how are we bypassing here? So what we are saying, see, here we are bypassing. What is previous? Previous is this and current is this. So current dot next is this. So what we are saying, previous dot next equal to current dot next. So we are bypassing these duplicate nodes, right? We are bypassing this duplicate nodes. Previous dot next equal to current dot next. So that's what we did here. And simply, anyways, you want to advance the current pointer, right? So in this way, we are advancing the current pointer. Okay. So in this way, we are going to remove the duplicate elements, right? We are going to modify the pointers and we are going to remove the duplicates, right? So here, right? In this case now, previous is here, right? Previous is here. Okay. Wait, hold on. So this was previous and yeah, this was current. Now current is here. Current is here. Okay, current is here. So what we are going to check, if previous is here and current is here, right? Previous is here. So what are previous dot next? What is previous dot next? Previous dot next is this, and current dot next is this, right? So these both nodes are not same. These both nodes are not same. So simply what we are going to do, simply we are going to break out of this while loop because these values are not matching. 35 and 49 are not same. So simply what we are going to do now, previous dot next indeed matches to current. So previous dot next, right? This is current here. So this previous dot next is current. So simply what we are going to do, we are going to update previous to this node, right? Previous. And simply we are going to advance the current pointer. Current pointer will be here. Now again, we'll check again the same, right? If previous dot next, what if previous dot next is this, and current dot next, current is here, so current dot next is this. So simply this both matches, right? So we're going to advance current. Again, we are going to check previous dot next, this and this. If it matches, no, it does not match. It does not match. So we are going to break out of this while loop, right? We are going to break out of this while loop, and we are going to check. No, this is not the same. So we are going to bypass these nodes, the 49 nodes, right? In this way. So in this way, we're going to solve the problem. Simply what we're going to do now at the last, right? We're going to return dummy.next. So why dummy.next? Because dummy.next anyways is pointing to the head, right? So it will give the new head basically. Dummy.next, whatever is the resultant list, it will return that. So let me compile this. I hope you have got the solution. It's a bit tricky, but yeah, there's some problem now. Let's quickly see. No dummy. Oh, okay. I okay. So I mistakenly coded this in C++. So I should have, yeah, should have coded here. Let me compile. Yeah. Yes, the test cases seem to pass. I hope you've got the solution. Okay. Okay. So thanks for watching. Okay, please subscribe to my channel. Here, the I won't show the C++ code today. It's almost the same. Only the difference will be will be needing this arrow pointer. Okay, we'll be needing this arrow pointer. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.